Hey guys, welcome back to another mole video here. We're going to take a look at doing one more step with this as we continue this unit for moles and stoichiometry. So in today's lesson, we're actually going to take the mole and now we're going to actually change it to grams. So we're going to go from moles of something to grams of something. And this is for mole worksheet number 2 that you're going to be taking a look at. So let's take a look at this lesson. We got two quick little slides of notes and then we'll do some examples and we'll get you out of here. So let's take a look. Now here is our definition that you guys want to take a look at and you're going to want to know this. Molar mass. The molar mass is the mass of 1 mole of atoms, and it's equal to the atomic weight from the periodic table. So, for example, when I have 1 mole of carbon, we say that it actually weighs 12 grams. Well, where did this 12 come from? Well, like we said, this is the mass from the atomic weight. So what do I have to look at? I actually have to look at the periodic table. When I look at the mass for carbon, here it is. Carbon has a mass of 12.01 grams, or AMU. This is the mass of 1 mole. So carbon, a mole of carbon is equal to 12 grams of carbon. When I look at a mole of oxygen, it says it equals to 16 grams. Well, the reason why 1 mole of oxygen is equal to 16 grams is that the formula weight, or the atomic mass, I should say, of oxygen is equal to 16. So oxygen has a mass of 16 AMU. A mole of oxygen is going to have a mass of 16 grams. So that being said, the question is, what does 1 mole of lead weigh? Well, 1 mole of lead, we have to look it up on the periodic table. Anytime we're looking at the mass of something, the mass of a mole, we have to look it up on the periodic table. So I'm looking for lead, Pb. So I want to find lead. Here it is down here. Lead has an atomic mass of 207.2. Guys, we're just going to round these to make these calculations simple. 207.2, let's just round that to 207. That's the mass of lead. Now when I'm looking at this for gold, let's do the same thing. Look it up on a periodic table. We want to know the mass of 1 mole of gold. It's going to be equal to the mass of gold from the periodic table. So when I look at gold, AU, here's gold. The atomic mass on the periodic table is 196.97. Let's round that. Now I have 0.9, so let's round that to 197. So we're actually going to round the mass of gold to 197, and that will make our calculations easier. So it's a pretty simple way to look this up, but the difference between what we did last time and what we're doing this time with mass is that you actually have to look up this conversion factor. These are the conversion factors that we're going to use. A mole is going to be equal to the mass from the periodic table. You're going to have to look up that conversion factor every time you do these problems, as opposed to last time when we looked at these, you guys already knew our conversion was right here. 1 mole was always equal to the same amount, 6.02 times 10 to the 23rd. Today, we're looking at this conversion, right? A mole of something to the mass of something. When we look at this conversion, we have to look this up, and you see it. It's equal to the molar mass, and where do you get that from? It says it in parentheses, the periodic table. So when we do these conversions, you actually have to look them up on the periodic table every time to do them. Now, all of the examples that we've looked at thus far have been for individual elements: carbon, oxygen, lead, gold. What if I have a compound? Well, we're going to do the same thing. We're going to be looking up the mass, but we have to add it up. And this is where we get into the concept of a formula weight. The formula weight is, well, like we said, you have to add it up, the sum of all the atomic masses of the atoms in a formula. So when I look at H2O, this is a compound, it's a formula. I have hydrogen and I have oxygen. When I look at the formula, I have 2 hydrogens here, and I have, well, there's no number next to the oxygen. That means I must have 1. Now, just like we did before, we've got to look up the mass of these elements from the periodic table. So let's pull up our periodic table to take a look at them real quick. Hydrogen has a mass of 1.01. I'm going to round that just to 1. Nice and easy. So hydrogen has a mass of 1. I'm going to want to multiply the number of atoms that I have by the mass. Oxygen, we looked it up earlier, we'll look it up again, has a mass of 16. So that's the mass that I want to use for the formula weight. Oxygen has a mass of 16. So when I look at this, I have 1 oxygen, and that has a mass of 16. Now we have to do this math here and add those up to get the total weight of this formula or this compound. 2 hydrogens, each with a mass of 1, that's going to give me a total mass of 2 for my hydrogens. 1 oxygen, each with a mass of 16, that's going to give me a total of 16 for my oxygens. When I add those 2 up, I'm going to get 18 grams. So exactly what we did. I had 2 oxygens each with a mass of 1, that gives me 2. I had 1 oxygen with a mass of 16, that gives me 18 grams. Let's take a look at the calcium chloride. You guys already saw the answer there, a little sneak peek, 111. But let's take a look at how we do this. Looking at my formula, I have 1 calcium, so I have calcium. There's 1 of them there. Looking at my formula, I have 2 chlorines, so I have Cl, that's 2 chlorines there. Let's take a look at the periodic table and look at their individual masses in order to figure out what their total formula weight is. Calcium, down here, it has a mass of 40.08. Let's just round that to 40. So calcium is going to have a mass of 40. So I have 1 calcium atom with a mass of 40. When I look at chlorine, here it is. It says 35.45. Hey, this is the one atom that we're going to round a little differently than in the other ones. We've always rounded it to whole numbers. This one I actually want to round to have a fraction in it, or not a fraction, a decimal in it, I should say. I want to round chlorine to 35.5 instead of 35.45. So when I do this, I'm actually going to use 35.5 all the time for chlorine. Now, I've got 1 chlorine with a mass of 40, multiplies those together, that gives me 40 for my calcium. Calcium contributing 40. When I do my chlorines, I've got 2 chlorine atoms here in my formula, each with a mass of 35.5. You multiply those two together, and you're going to have 71. So 40 plus this 71, so 40 plus 71, 0 plus 1, 4 plus 7, that's 11. That means I'm going to have 111 grams for my formula weight for this compound. All I did was I looked at how many molecules I have here, and I multiplied it by the mass on the periodic table to get the total formula weight. 1 mole of calcium chloride, CaCl2, has a total mass of 111 grams. So we're doing these conversion factors, and we're going to be converting moles to grams and grams to moles. The difference is, instead of having this static conversion like you guys had before, a mole is always equal to 6.02 times 10 to the 23rd molecules, this time we have to look it up from the periodic table every time. Let's take a look at some examples on how we'll do these problems. So we're using that same conversion chart. We're using this flow chart that you guys had. But remember, for right now, we are only looking at half of it. So we are folding this bad boy in half, and we're only worried about the left side of this. So this is really what we're going to be using. Let's do these problems. Number 1. I have 1 mole of ammonium acetate, big old compound, nasty looking. So right away what I do when I do these problems is I make a list of all my things that I have here. I have nitrogen, I have hydrogen, I have carbon, I still have another hydrogen. We're going to put that one right there, or I could do it separately, either or. Right? Let's do it separately just to keep it simple for us visualization here. And I have an oxygen here. Now, I have nothing next to my nitrogen, that means I have 1. I have 4 next to my hydrogen, that means I have 4. I have a 2 next to the carbon, that means I have 2 carbons there. I have another hydrogen atom with a 3 next to it, that means I have 3 more hydrogens. And I have another oxygen atom here with a 2 next to it. All I did was I counted up the atoms that I have. The next step that I can do is look up the mass of each of these elements on the periodic table. So, here it is. Nitrogen has a mass of 14.01, so I'm going to use 14 for my nitrogen. Nitrogen has a mass of 14. We looked up hydrogen earlier, but just to remind you, hydrogen has a mass of 1.01, so we're going to say that hydrogen has a mass of 1, and we can use that for both hydrogens because the mass is not changing. So I'm going to put that in for both spots. Carbon, we looked it up earlier, but just to remind you, I'm pulling this from the periodic table, and on the periodic table it says 12.01. Let's round that to 12. So carbon has a mass of 12. I got 1 more oxygen here. Look that up on the periodic table. I believe we did already. Oxygen has a mass of 16. That's what I want to use when I'm doing this. So oxygen is going to have a mass of 16. Now we want to do these calculations. So I'm going to just add all these up here. We're going to multiply all these up and then add it up to get my sum, to get my grams. I have 1 times 14, that's 14. 4 times 1, I got 4. 2 times 12, that's 24. 3 times 1, I got 3. 2 times 16, that's 32. Now what we want to do is add these all up. Let's just do this with a calculator. No mistakes. 14 plus my 4 plus 24 plus 3 plus 32. Add these all up, and what I have is, for this 1 mole, I have 77 grams. That means that 1 mole of this NH4, C2H3O2 has a mass of 77 grams. Now, this was easy because I had only 1 mole. Let's take a look at some other examples where I have more than 1 mole. Let's take a look at example number 2. And actually, let's skip number 2. Let's go to number 3. They want to know how many grams I have, but this time I'm starting out with 7.2 moles. Uh-oh. I have a name here. I've got to change this name into a formula in order to even start this problem. Dinitrogen trioxide. Ugh. Okay, this is a covalent compound because I have 2 nonmetals. I can also tell because I have my prefixes di and tri. Remember, when I have these prefixes, those are telling me the number of atoms that I have. So I have nitrogen right here, and I have oxide, that's oxygen. Figure out your formula before you can even do this problem. Well, if I have dinitrogen, that means that I have 2 nitrogens. If I have trioxide, that means that I have 3 oxygens. So that's N2O3. Now that I have my formula, I've got to figure out my conversion. Let's take a look. I have nitrogen here. I have oxygen here. I have 2 nitrogens. I have 3 oxygens. Let's look up the masses from the periodic table. I could tell you them if you look it up. Nitrogen has a mass of 14. Oxygen has a mass of 16. Those are the masses that we want to use in this. So nitrogen has a mass of 14. Oxygen has a mass of 16. So let's do this on the periodic. Let's do this math here real quick. 2 times the 14, that's going to give me a mass of 28. 3 times the 16, right? Let's punch this one into a calculator real quick just to make sure we don't make any mistakes. 48. Now we want to add these 2 together. So 28 plus the 48, that's going to give me a mass of 76. Now, we are not done with this one. What we just found out was that 1 mole of N2O3 has a mass of 76 grams. With this problem, we're asking us to change 7.2 moles and ask us how many grams are in 7.2 moles of this. So we've got to set up our problem just like we've been doing all the other problems. Start with what you know. I've got 7.2 moles of N2O3 down here. Take what you know, put it over 1. That's how we've started every problem thus far. We're going to keep it that way. Multiply by a conversion factor. I got moles of N2O3 up on top. Hey, every time, all the time, take the unit that you have on top, put it down on the bottom. The moles of the N2O3, they're going down to the bottom. What is my conversion factor? Well, here it is. That's what we just figured out. I'm trying to go from moles to grams. I'm going to use what I just calculated to do that. I have 1 mole of this, and it's equal to 76 grams of this. So 76 grams of N2O3 for 1 mole. That's the conversion factor that I'm going to do in this problem. I've got the moles on top. I got the moles on the bottom. Sounds like a song, right? I can multiply these together, and then I can get my answer. Multiply everything together on the top. 7.2 times 76. That's what we want to do. Multiply the top. 7.2 times 76. I multiply the top part of this together. 7.2 times 76. When I do that, I get 547, I believe is what it said, 0.2. Multiply everything on the bottom. Well, I got a 1 and a 1, so guys, anytime I have a 1 and a 1, I'm going to have a 1 on the bottom, and that means I'm just going to leave this number all alone. That means I got 547.2 grams of N2O3 for my answer. In 7.2 moles, I have 547.2 grams of dinitrogen trioxide. Hey, let's do another one. This one. 7 moles of sodium bicarbonate. Ugh, we got to take that name and change it to a formula again. Sodium is Na. We know that. We got to look up the charge of Na. So let's look at the periodic table real quick. It's in this group 1. That means it's going to have a charge of 1. So sodium is going to have a charge of 1. Bicarbonate. Oh, I see an ATE ending. Better pull out that gold sheet. Let's take a look at it. Bicarbonate, look it up. Bicarbonate is not the same as carbonate. Bicarbonate is HCO3 with a charge of -1. So bicarbonate here is HCO3 with a charge of -1. I got to criss to the cross these to get out the formula. So Na with a +1, HCO3 with a -1. Criss cross. My formula for sodium bicarbonate is NaHCO3. Before we even start this problem, we got to figure out, well, how much does 1 mole of sodium bicarbonate weigh so that I can figure out how many grams are in 7 moles of sodium bicarbonate. Let's take a look at how to do this. Na, pull it up from the periodic table. Na is going to have a mass of 22.9, so we're going to round that to 23. So sodium is going to have a mass of 23. Pulling that number from the periodic table. I've got one of these here, so I have one of these here, so I don't have to do any multiplication. Hydrogen, I've got one of these, right? Hydrogen, we said before, has a mass of 1. Carbon, I've got one of these, so I have 1 times my mass, and we looked that up earlier. Carbon has a mass of 12. Oxygen, I've got 3 this time for oxygen, pulling that from the formula, so I got to do 3 oxygen atoms times the mass of each individual oxygen atom. Remember, oxygen has a mass of 16. We looked it up here. Here it is. Okay, so oxygen has a mass of 16. We pulled it up earlier, getting that number from the periodic table. Let's do this, right? I got this is equal to, there's 1 sodium atom here, so that's 23 for my total formula. 1 times 1 is 1. I got 1 times 12, that's 12, and I have 3 times my 16, which is my 48. Let's add these together to figure out what 1 mole of sodium bicarbonate equals so that we can figure out how many grams are in 7 moles. I have 23 for my sodium, plus 1 for my hydrogen, plus 12 for my carbon, and plus 48 for my 3 oxygen atoms. That gives me a total of 84 grams. So this was 84. That means that 1 mole of this is equal to 84 grams. That's going to be my conversion factor. Let's set up this problem. Let's take a look at how to do this, and we'll do one more. I got 7 moles of NaHCO3. That's what I'm starting with. Take it, put it over 1. Multiply by conversion factor. Here I am. I'm starting in moles. I forgot to use the flow chart last time. Here I am. I'm starting in moles. I want to go to mass. I want to go to grams. What do? I use this conversion factor that I just calculated here from the periodic table. I got moles up on the top. They got to go down the bottom. Every time, all the time. Take the units from the previous step, put it down on the bottom. NaHCO3. And hey, I got this kind of right in the way, but it works out for me. I got 1 mole of this is equal to 84 grams. So 1 mole is equal to 84 grams. Let's see if I can slide this up here. So 1 mole of this substance is equal to 84 grams. That's what I want. Now, this is grams of NaHCO3. Don't forget to label everything. There we go. I got moles on the top, moles on the bottom. They cancel out. I got to multiply the 2 top parts together. 7 times 84 up on the top. I got 1 and 1 on the bottom. Tricky things happening. 1 and 1 down on the bottom. That means I got 1 on the bottom. 7 times my 84. Let's use the calculator. 7 times 84. That means my top part is going to be equal to 588. That means that I have 588 grams of NaHCO3 in 7 moles. That's how you do this problem here. I'm running out of room on these pages. That's what you got to do. I have 588 grams of sodium bicarbonate in 7 moles of sodium bicarbonate. Let's do one more. This one, right? This one is asking us, instead of going from moles to grams, so before we were going from moles to grams, this one we're going the other way. We're starting with the mass, we're starting in grams, we're going to go to moles. So let's switch it up here. I'm starting with 28 grams of this. I got to figure out how to go to moles. Now, our first step would be to figure out what my formula is, sodium bicarbonate, but guess what? We just did that on the last page. Sodium bicarbonate, we already figured out that that was NaHCO3. Remember? We crisscrossed sodium and bicarbonate. And we already figured out my molar mass. Let's see if I can actually just steal this from before. right? So I want to take what we did before, all of this right there, and let's actually take this and steal it for right here, right? So let's steal this and move it down. We already know that I have one sodium with a mass of 23. I've got one hydrogen there with a mass of 1. I got carbon with a mass of 12. This is just moving all over the place, right? There we go. Computer's going a little slow. And then when I added this whole thing up, that gave me a mass of 84. So we already calculated out the formula weight for this from the periodic table. We did it in the previous problem. If you don't understand where that comes from, talk to me tomorrow. We'll figure it out. I promise. But let's take a look at how to do this setup. So before we were going from moles to grams, this time we're starting in grams, and I'm asking you to go to moles. So let's do this. 28 grams of NaHCO3. That's what I'm starting with. Taking this and I'm putting it over 1. You got to take whatever you know, put it down on the bottom. Take the units from the previous step, put it on the bottom every time, all the time. Right? So let's take a look at how we're doing this. Guys, I am starting out. I'm in grams. I want to go to moles. So let's remember how to do this. Here I am. I'm in mass. I'm in grams. I want to go to moles this time. I'm trying to get over here to the moles. It says that I need to use the molar mass from the periodic table. Here it is. We calculated it. If I have 1 mole of this, it's equal to 84 grams. So what number goes down here? Well, I have an 84 next to the grams, so that's the number that's got to go on the bottom. This time I'm dividing. I'm not multiplying. 84 has got to go on the bottom because my conversion says there's 84 grams for every 1 mole. 1 mole is what goes on top. 1 mole of NaHCO3. Multiply the numbers on the top and the bottom together. I got 28 on the top. I got 1 on the top. Multiply those together. 28 and 1 on the top. That's going to give me 28. Whoopsie. Right? On the bottom, I've got 1 on the bottom, and I got 84 on the bottom. Multiply those together. 1 and 84. That's going to give me 84 on the bottom. I'm dividing. I'm not multiplying for this one. I need to do 28, and I need to divide it by 84. So 28 divided by the 84 that you have on the bottom. This is going to give me the number of moles that I have. I get 0.33 moles. That's the unit that I was in. My gram canceled out. I'm in moles of NaHCO3. So what I just said was that 28 grams of this is equal to 0.33 moles of sodium bicarbonate. That's how you do a gram to mole conversion. Check this video out. We're going to do some practice problems in class. We'll get this down. Talk to me if you have any problems. That's going to wrap